It's a material that actually gets colder when it's exposed to the sun. How real is so-called spotted?
Are in the stage that we are now producing it. A coating material with these nanoparticles embedded inside that looks pretty much just like a wallpaper. In Israel, Cyprus, in Brazil, in the United States, in Japan, in Singapore, in South Africa, in Spain, and it works. So the temperature that we are measuring constantly on our material below or above doesn't really matter, are always sub-ambient temperatures, works every time the same thing, meaning at noontime when it is the hottest hour of the day, temperature that you will measure on the SolCold material is colder than the air floating around it. Weirdly to say, it is colder to be under sunlight with the SolCold than to be in a shaded place just next by.
Welcome to the Ageas podcast. Buckle up. This episode is brought to you by Cards Biz, a business card too good to give away. This episode is brought to you by Better Weight for Life, transformational weight loss aid, led by U.S. board-certified physicians, providing access to GLP-1 medications like Wegovy and Zepbound that are proven to help you lose weight and keep it off.
Hello, Yaron.
Hello, hello.
Looking good.
Looking dark compared to you.
Well, it's like I'm a whitish man. I can get away with it.
I should definitely get this round lamp.
Yeah.
The first conclusion from talking to you.
It's all about good lighting and deep fake AI, right? It's like, and then everything looks good.
All natural, Chagai, no fake AI.
All natural. So to the people out there that don't know who you are, who is Yaron?
Yaron is a guy. Oh, this is a difficult question. We start with the difficult ones. Guy who is 48 years old, who is married and has 3 wonderful kids, who loves them very much. And one of them is actually at work with him today because he doesn't have school today. Yaron is an entrepreneur that I would say pretty much most of my adult life was an aim for that part as an entrepreneur. Took me some time to get there. Yaron is a sportive guy, likes to play a lot of tennis, likes to ride bicycle. He's just, I don't know, a simple guy, straightforward guy.
So, and I'm going to jump and tease a bit ahead. I think most of the people that have been in this podcast so far have been from the software world. And you are from the deep tech and the material in the material world. And I'm already teasing because when I first heard it from you, I said, it's a material that actually gets colder when it's exposed to the sun. So maybe without getting too much into the company yet, you're the founder and the CEO of SolCold. So what is SolCold and what do you guys do? And what is the science fiction we speak of?
I must admit, every time somebody's saying science fiction, or even the worst, there is the worst phrase, perpetuum mobile. These are the stuff that I don't like. And then I need really to go into the physics and to explain, because these kind of things need to get off from
so
people.
Expunge me from my ignorance.
It's okay. So SolCold is a startup, and as you mentioned correctly, in the materials domain, that have developed a technology in the form of nanoparticles that once exposed to broadband and incoherent light, which at the end is the sunlight, these nanoparticles, the miraculously thing that happens to them is that they are absorbing the photons coming from the sunlight, specific ones, then making some kind of an energy jump and an energy crash. And in this process, they are emitting back a higher frequency photon. Now, that doesn't basically mean much to regular people, okay? So one photon equivalent to another photon, but it has a great deal of influence in it. The energy of photons is equivalent 1-to-1 to their frequency, meaning higher frequency photon means more energetic photon and vice versa. That means that if a nanoparticle is actually getting a photon and then emitting a higher frequency one, it means that it is reflecting back higher energy than it has absorbed. Now that fundamentally cannot happen in reality. You can to get amount of energy and give back higher amount unless you are taking energy from elsewhere and adding that to the energy that you have received. And this is exactly what happens inside these nanoparticles. The energy that they are taking is the energy of heat from the inside, adding that one to the photon and in emitting the higher frequency. That means in the process of it, they are losing their own energy. And if you're looking at not a single nanoparticle, but millions and millions of nanoparticles on bulk, all of them losing very small amount of their own energy, all of them are actually cooling down temperature-wise. So you can actually measure that. And this is what we have been doing. We started off from the concept of it is actually taken from a research field named laser cooling of solids. You can read it up afterwards. Laser cooling has two different ways of making it. One is in the form of gas-like, and the other one is in the form of solids. Slightly different ways of making the two of them, but both of them, at the end, you're hitting a laser, you're hitting a photon, you're hitting a very specific amount of frequency of photons, amount of energy on the photons onto material, and then getting back higher frequencies, and then you can measure the temperature decrease. You have several universities that are working on this globally, and you have some fantastic results on it that some researchers managed to get even to minus 100 degrees difference between chunk of nanoparticles before and after. And we've taken that one and said, listen, to maximize it with the laser is something that is known and something that is being done at universities. We're not interested in that one because laser is a very energy consuming power source. Doesn't make any sense to do that with a laser, to go cryo cooling, unless you look at the benefits of non-moving parts as the gas, the pipes, etc., that are being used today. Otherwise, it makes no sense and energy-wise. So we said, hey, why not looking at the free source of energy that we have? It is the sunlight, but the problem, of course, it is not a laser. It is not monochromatic and it is not coherent, meaning the photons are going everywhere with different phases every time and with different wavelength every time. And then the question is, what do you do? And then that was the beginning of it. So the theory of it was that you can actually manipulate the same technique, not as a monochromatic light, but as a broadband and incoherent. We managed to, at the first feasibility test, we managed to do that with a 10 nanometers incoherent light, then broaden it and broaden it and broaden it. Today we're working with 100 nanometers of incoherent light, meaning basically material is exposed to the sunlight, natural environment. We are filtering out before and after. We're working now with from 500 to 600 nanometers. And then all this thing is coming inside the material, triggering the phenomena, emitting higher frequency light, and then you get the temperature reduction already measured in the natural environment.
Let's go from the science to the real world and help people understand how real is so-called spotted.
Well, we are in a stage that we are now producing it. We are producing a coating material with these nanoparticles embedded inside, coating material that looks pretty much just like a wallpaper or a big sticker, a very thin material made of stack of layers, one on top of the other, and then the nanoparticles inside. And we have installed that one. So on several projects in Israel, Cyprus, in Brazil, in the United States, in Japan, in Singapore, in South Africa, in Spain, and it works. So the temperature that we are measuring constantly on our material below or above doesn't really matter, are always sub-ambient temperatures while it is exposed to the sunlight. That means, contrary to what we usually think, everything that is exposed to the sunlight will heat up from a lot, like our dud shemesh
Water heater.
boiler, solar boiler heater.
Yeah. Solar water heater. Yeah.
So that they have a black plate and then it heats up to something like 90 degrees Celsius. If you look at the rooftop in Greece that are all colored white, or the buildings in Greece that are all colored white, which is for a very good reason. White is a very good reflective of solar radiation. That means it will reduce the heat load from being absorbed in the building. So, but everything, even these white reflective coatings are outside, they are still heating up, but a little bit. Nothing pretty much when it is exposed, nothing at all. When it is exposed to the sun, it can be colder than a shaded place because it is exposed to the sunlight. And this is exactly what we have achieved. And we've been doing that on really numerous of objects globally with customers, on ourselves, demonstrate on containers, on silos, on rooftop of buildings, on pipes, on tents, on batteries, on electronic cabinets, you name it, really. We're working with defense companies, working with beverage companies, working with storage companies, and all the big names and the middle names and the small names. And it works every time the same thing, meaning at noontime, when it is the hottest hour of the day, the temperature that you will measure on the so-called material is colder than the air floating around it. Cold, meaning that it is weirdly to say, it is colder to be under sunlight with the so-called than to be in a shaded place just next by. And with that result, now we are moving ahead. It is not anymore just okay. It's a fantastic technology, a fantastic theory. Let's see if it works in real life. It does. It is already there.
So let's go a bit back. How did this become a reality? How did you even get to it? And what's the origin story of SolCold and the journey that you as Yaron went to get here?
Yaron was a student in a master degree for electronic engineering in Tel Aviv University. The field that I specialized in my master degree was lasers. And I was really intrigued with this phenomena that you can manipulate energy levels in atoms and in molecules using lasers. Usually materials, their basic structures are basically made of energy levels, meaning everything that you saw really when you learn scientifics, when you have the core and then all the electronics running around it, etc. At the end of it, they can all arrange themselves in very distinctive ways that are equivalent to energy levels. And it's quite astonishing that materials can be either here or here, but cannot be in between. Or they can be here, here, and here, and here, but cannot be anywhere else. And you can actually manipulate them from moving to one part to another part to another part just by exposing them to the very specific energy gap that allows them to go from one state to another state. And the weird thing here is that you can actually not force them with energy to go up. You can actually force them with energy to go down, which sounds really weird when you think about it in the first place. You can give energy and you force some material to lose energy, which is equivalent to the energy that you receive, that you get bringing to it, but it does. And there are several conditions that it can happen. Okay, it doesn't really happen naturally. And of course, materials can arrange themselves in the naturally, depending on their temperature, in a Gaussian way of, etc. And then one day I was with my girlfriend back then, and it was a very hot day, and our air conditioner was working rather poorly, and I was hot there in that day, and I was starting to think, why the hell, which is something very strange to think about, why the hell do we even invest energy in the first place to cool down, which is a state of a less energy to begin with? Isn't that weird?
That's the same thoughts I have every time I am with my significant other. That's the same thing that's running in my head.
I'm sure it does. I mean, we bring from coldness to hotness, you invest energy. That makes sense.
Yeah.
Situation is more energetic, but going to the other way, also you invest energy, but that doesn't make any sense, right? You should get the energy. Anything, one thing led to another, and then my study, my master degree went inside to my thinking, to my thoughts back then, and I said, why not? I mean, there's so much energy in this hot place. I mean, I can collect it pretty easily just with the lasers, and then force the atoms and molecules to reduce their energy, and I can get extra energy. And then I thought, okay, this is. I mean, you're just a master student. You're in the academy. This kind of thing, which is very raw to begin with, doesn't really make a lot of too much sense. It is quite difficult. And then I pretty much said, okay, this is very interesting. This is a magnificent thing that you can actually drop down the temperature, not just energy level, but actual temperatures. But then I left it. I just said it is just, I don't know what to do with it. I just left it. And then I went to the usual course of an electronic engineer. I went to work as an R&D engineer, started working with Elbit, and then worked for a company for the competition company called Elta, and then went to work for a daughter company of Elta called Bats. I just spent several years in the defense sector. Electronic engineer, a lot of radars, a lot of optics, a lot of RF, a lot of all these kind of nasty words that electronic engineers like to use. And then several years passed by, and this idea that I had a few years before in my master degree was always pretty much on my mind. And I said, this could have been nice to do something about it. And then
I have to, like, what was so compelling about the idea that it kept coming up and up in your head? What drew you to that from all the other possible things?
I don't know, actually. I just find it so fascinating.
Okay.
Pretty much fell in love with this, but I didn't really know what to do.
Okay.
I didn't have much other ideas. I'll tell you afterwards. One stupid idea that I had, and then I did it, and then it was really never mind. But putting that one aside. Anyway, so at a certain point, after a few years, when I thought about it again, I thought, hey, why not, instead of using a laser to cool down these hot objects and then forcing them to lose energy and cool them down, why not use the sunlight? It's a free source. I mean, we are talking about the quantization of the photons. It doesn't really matter the direction, the difference of the phase. I think it could be done, and pretty much this is the moment that I started taking steps towards it. So I started slowly to tell that to people around me, and then one of the persons that I told was a friend of mine that we worked in the same company, and then he said, "Well, this is fascinating. This is really fascinating. Let's do something together." So we joined together. His name is Gadi. He's now on the board. And then I thought together to ourselves, what's the next step? I mean, we have a nice theory. How do we make a company out of this? So we went to consultants. We went to people. We did some mistakes. Eventually, we ended up looking for the leader of research of the laser cooling of solids in Israel. He's a physics professor. His name is Yaron. And then we went to see him, and I described to him what exactly do I want to do. And we sat down in his office, I think like 4 hours there, and then discussing and making some kind of an analysis and then calculation really to see where it can lead us. And he was also enthusiastic of it. And then we went, 3 of us. Okay, so now what do we do? I mean, it's a semi-academic type of idea. You cannot really build a company out of it.
It's not like, hey, let's put a website and start selling.
And start building a mock-up with your laptop in 3 months. I mean, you need laboratory, you need equipment, you need materials, you need a lot of testing even before just start building anything. So that's when we said, okay, we just need some small amount of money, and then we can work at the laboratory of a guy, Professor Ron, at the Hebrew University, and then do the first step. First step is, okay, take the theory, let's prove it, just the first step that it can be achieved. So we went to meet a few companies and then few angels, and then went up to have 2 groups that wanted to make this first investment, very small investment. One of them wanted for a lower valuation, but they wanted to invest less and get less percentage. The higher wanted slightly higher valuation, but wanted to invest more and get more. We went to the lowest one. Then started working at the university, working there for 1.5 years. What we did there was prove that we can emit higher frequency, meaning up conversion, on a solar simulator on a nanostructure that we have synthesized with a frequency gap of, I think it was something like 25 nanometers. Now, when I say it like that, probably doesn't really mean anything, but this was a big.
So explain to us mortals, why is this a wow?
It's the first time experimentally that the up conversion, the basic phenomena of the laser cooling of solids was tested successfully under non-coherent, non-monochromatic light. Meaning all the time until now, it was only done by lasers to maximize the efficiency. We are not talking about any more maximizing. We're talking about at the end to use the sunlight. So we needed to go from a laser like this and broaden it a little bit. And then instead of getting the same type of photons, going slightly crazy on the photons. This was the first time ever that this one was tested successfully. That you can take this gap, entire gap, not a single one, the entire gap, emit it on a structure, and then the structure will emit it shifted, but not shifted to lower energy, but shifted to higher energy. Then you can actually prove that you can go from that one into the cooling part. I mean, at that point, probably some of the photons were being absorbed and then heated up. Not all of them, of course, then emitting the higher frequency. Some of the higher frequency were not directly from the cooling, but part of another photon combination, double photon. There are several things that can happen simultaneously. But the fact is that some of them, for sure, had one photon in, one photon out, up converted and dropping down their energy is proven.
And it's very interesting because you're talking about and you're getting excited, right?
Yeah.
You're getting excited. But for somebody who for most of his operation doesn't deal with deep tech, right? So here's what I'm hearing. You're saying you had this momentous moment where you proved it's possible, right?
Mhm.
Where it's possible. You don't know if it's scalable. You don't know if it's economic. You don't know what the business model is yet, right?
Yeah.
So how do you deal with that?
Not very successfully, I must admit. So that was the end of 2017. That one
Okay.
when we had these results and then we published them. From that point onwards, you're rightfully say we are not anywhere close a product. We don't know if it is economically viable. We don't know if we can get to the final point that it will work as a product and can be sold. We don't know anything of it. So we have the first step. So we are still basically under more or less an academic type of study of research. And then what you do? So we said, okay, everybody raises money for their startups. Let's also raise money for our own startup. I think we have the feasibility test. We showed that the first ever in the world, the up conversion was successfully under broadband incoherent light. Okay, let's raise money. And then we went to some VCs and then some angels and then some CVC and even submitted a grant for the Israel Innovation Authority. And we got a no, pretty much across the board. So that was the situation. I mean, we worked on that one 6-7 months and nothing happened. Nobody wanted to touch it. I mean, it's too early for companies. It was probably too early for VCs and the angels. Okay, so proven this one. Okay, and I mean, and even the Israel Innovation Authority didn't want to touch it, which is, I think it's a bad thing for them. They should have at that point. So I think it was.
Look, I don't know if it makes you feel better, but there's another person that I interviewed that's also going to show up, the founder of Aria, and without getting too much into their story, but they were the exact opposite from you, but they had a similar experience. They managed to do a no-code MVP, got to $1 million ARR in 1 year, and 197 investors told them no. So it's an experience. So I'm gonna ask you the question, but I asked him, like, what made you continue at this point? Like, it's like you're getting all this hits in the face.
I remember back then we set, I think it was something like December, and we set me, Guy, Gadi, the founders, also with the Zevi group, which was one to give us the initial money, the pre-seed. And we said, listen, it's quite difficult to raise money. Let's give it another effort. And we set up, okay, this is the deadline for us, the end of March 2027. If we succeed on getting a term. So at that point, when they said, okay, so maybe we should leave it, maybe we should stop, I told them at that moment, I said, fuck that. I'm pushing now to everything I have now. This is really not really the time. It's a good thing. And at that point, I left my job. I said, I will give this now my 100%. This cannot be true. And then spoke with a friend of mine, and then we thought about, okay, you know what? If nobody, no, not investors is interested in this, but as a product, what we can imagine of doing is something very intuitive for people. I mean, nobody cares really about the nanoparticles inside. Nobody cares really how it does what it does. At the end, it's a coating material that will cool without electricity.
Yeah.
And when I say it like that, people understand that very intuitively. So I said, let's go to the people. And then we said, let's do a crowdfunding. So we looked at what's the options in the market, and then there were like 3 companies in Israel that were doing that, and we met all 3 of them, and we got the best deal in a company called Exit Valley, and said, okay, so this is our last shot. Let's do it. And then we got to gather the group of for cinema students from Tel Aviv University to make the video. Actors, amateur actors. It was fun, really fun. It was really low budget type of marketing campaign. So the video, all the text, all the pictures, everything that we set up to do there, all done by amateurs, students on 0 budget. And then we launched it into the air, and we ended up being I think it was number 3 or number 4 until then ever best campaigns at Exit Valley. So it was a huge.
How much did you raise?
$150,000. And then, by the way, during that period, we resubmitted to the Israel Innovation Authority, and now we got the grant from the Israel Innovation Authority. So we ended up at middle of 2018 with like something like $750,000 from both of them. And that was really the first step. And from that point, it was, I think, a regular type of startup that recruit the first employees, and then moving out of the university, and then develop, and then pitching in competitions, and then investors approach you, and then we get the round A, and then the safe round, and then a product, and then customers, and then here we are today with $14 million invested to date. 27 employees in the company: chemists, physicists, materials engineering, thermal engineering, photonics engineering, sales, production. I'm actually producing. I'm a industrialized person. I have a small factory just below me producing the cutting edge coating materials, and then sending them all over the world to be coating down objects to cool down without energy. So that's where that was the short story from.
That was the short story. So it's like it's very interesting, but I want to go back into it, like because I think there's something that a lot of entrepreneurs have to deal with. Is like, when do I not waste my time and give up, and when do I say, as you said so eloquently, fuck it, I'm gonna gambles and and take the plunge and try to make it happen. And in some ways, sometimes you manifest destiny, right? Through sheer luck and will, you just make shit happen. And sometimes it doesn't work. But can walk us with that mindset.
How do you know, really? How do you know? You don't know. In fact, you don't know. It's a matter, it's again this same phrase of don't fall in love with your idea too much, right? But sometimes it's like it's bigger than us. So we are in love with it, and it doesn't really matter how many no's we're gonna get. It's like we know better. But obviously, sometimes I suppose it is not a success story.
Yeah, because there's something misleading in my question, I admit, and also somebody who has experienced it themselves. It's like, I'm not trying to ask for certainty. I'll say from my experience, every time I was in a similar situation, I was both right and wrong, right? There was instances that I fuck it, and then I spent too many years on something that wasn't worth investing at. And sometimes I said, fuck it, and we made reality happen. Like, we created reality. So I don't pretend in the statement, because I think what people sometimes want to hear is like, I just knew it's going to happen. I got certainty. It's like, maybe, it's like, you don't know. You maybe, but still, I'm trying to get into the mindset, like, what enabled you to do it?
You don't know. This is a very, very honest thing to say. I also didn't know. I just believed in it really, and I wanted it too much. And I hated the fact that this kind of, we got to a certain point that I hated the fact that this should all go to waste. There is no certainty really. I could make the effort certain amount of time and be unsuccessful, and then I don't know what will happen. And then we probably will not have this conversation. So probably I don't have a good answer for that.
Yeah.
Honestly speaking, it's a matter of hunch. And sometimes you're right, and sometimes you're not.
Yeah. Do you think that attitude exists today in the company?
That attitude?
Yeah, that mindset. But like I'm like we're gonna make things happen by hook or by crook, as they say. It's like that.
Most definitely.
In what way?
Don't give me short answers.
Yes. Don't give me short. Don't give me short answers.
I'll say this. At SolCold right now, as I mentioned, there are 27 people, right? The SolCold team is pretty much the most dedicated team that I ever laid my eyes on. I mean, I worked in other companies, and I know what it's like to be an employee of the company. I never had this sense that I feel, not for myself, but from other people at SolCold, other people that want to contribute, wants to sometimes to stay and work on Fridays and sometimes even come on Saturday evening because we have to get this one done. And people that are, okay, we have our investors coming from Japan on this date, and you see PhD guys, sometimes, helping to clean some part of the roof and make it ready for the demonstration, even though it is completely 100 degrees apart from what they are supposed to do on their day-to-day job, and dealing with the fire department and dealing with everything, which, I mean, it's a startup in the materials domain, probably completely unlike a software type of startup. We're dealing with so many things that are irrelevant to the development and irrelevant for the product. You're dealing with the city hall, you're dealing with the Ministry of Labor, you're dealing with the Ministry of the Environment, you're dealing with the fire department, you're dealing with authorization, regulation, you're dealing with logistics, you're dealing with how does a supplier for raw materials, how will they enter with their truck to us, so it will be the easiest way to put it into production. I mean, so many things that this is just a glimpse of it, that usual startups in the software domain doesn't even need to think about. And now we need to think about, I mean, your team is your team, and your team is made mostly from researchers, and some of them are from sales, and some are for just regular people that need to produce. Who's going to deal with all these kind of things? And everybody's dealing with everything.
Yeah.
And I think this sort of a
mission-driven attitude. Mission-driven attitude.
So this mission-driven attitude, in Hebrew it sounds better. I must say it's a single word in Hebrew. This mission-driven attitude is something that is.
Well, you could say obsession if you want one word, right? You could say this obsession for success, or this obsession, right?
It is shared. This is what I want to do. By the way, we did because we're doing a project with Amazon. So once you do a project with Amazon, they have like tons of formalities that you need to fill up.
Yes.
And one of these formalities is that how often did you do a survey amongst your employees regarding their well-being and their work-life balance and la la la? And we never did that, of course. So we said, you know what? It's part of the Amazon requirements. Then let's do that. So me and Tish is our admin. She did most of the work, I admit. Drafted the questions for employees, and then we send it to all of them, and we say the reply is anonymously, so you don't need to identify yourself, just give your honest reply, and we cannot identify you, so we don't register, no names, no nothing. Just click the link and then and some of the questions that we added was relating to the how do you really feel as an employee of SolCold. We asked that in different questions, in different ways. So, will you recommend your friends to work at SolCold? Do you feel do you understand thoroughly the mission of SolCold? Do you identify with it, etc.? And of course, we did a lot of other questions, which is more related to the work-life balance, and do you have the tools to make your work, and yada yada yada. And for pretty much all the other questions, we get, we'll say on average, something like 75% positive, between good, very good, and excellent. That the rest, not so. But specifically for the question that related to how identify you with SolCold and its target, and you believe in it, it was like a fast 90+%. So that was really, I mean, we have created really something that we all share here. So I like it anyway. We need
It's clearly you're proud of it. I mean, it shows on you. You're clearly proud of it.
The conclusion from the survey was that we need to make more company meetings. Now we are making them every quarter, and also an evaluation for employees. We also added unanimous box for complaints in the toilet, which is the only place without camera. Also,
Okay.
one of the conclusions.
People leave complaints.
Still no. I'm checking the box like every week.
Interesting. So, okay, so there's actually two directions we can take this, but okay, but let me one more question about this, about the mission and the people before we move on. So, how do you hire for that?
How do we hire people?
Like, I mean, basically, you got the results, right? You got the results you were happy with, right? Like, I'm assuming that the skill sets and things like that you managed to get right, because it's like, does the person know how to do the technical work? But
Yep.
how do you hire for this this mission-driven attitude or even obsession?
Yeah, this is a good question. I mean, you have some employees, they are ones that approached us that we didn't really like publish an ad. We need this, and then people reply to that one. Sometimes, I mean, we have several employees here that just approached us directly. This and that, what you're doing is fascinating. I really want to be part of it. Consider me, pretty much, or even come here to pay us a visit. I really like these kind of people. Honestly, I really like. I mean, we have several of them. They're pretty much the best in terms of the dedication and really the mindset to do something which is beneficial for the planet, which is economically, which is a startup, which is materials. Each one of them from the different angles. But they're still the minority, of course, of the people. Most of the people are, we published an ad and then people replied, of course. I think the recruiting procedure here at SolCold is probably similar to a lot of other companies. You have the manager that is interviewing, you have myself always interviewing the potential employee, and we have an outside HR person also interviewing. And then we do a combination of the three. I think on that sense, it doesn't really differentiate from other companies. Probably the thing that differentiate is the way we are conducting these interviews, which is not by the book, meaning we don't have this set of questions and then give me bad experience, give me good experience, give me your worse, tell me something that's good about yourself, bad about yourself, an example of this one, what would your former employee, etc., which are the regular types of questions. When I interview people, first I like people that are smart, meaning I don't give them a math quiz question answer to this one. I usually go to them on what they did before in their last position, and then starting digging really, really deep into what they have done. And then it's a conversation when I did it. It's not really a question and answer. It's a conversation of going through the details of what they did. I like people that were enthusiastic about what they did, know exactly what they did, why they did what they did, what's the result of what they did, how can they make it different, the devices that they use, the machine that they use, they understand how they work, they understand why they give such and such reply. And then these kind of people that are smart, that are enthusiastic about what they did before, they put their mind and heart in it, these are the ones that I like to set up together.
Let's talk a bit about, so you mentioned Amazon as a client. So can you tell us a bit what you do for Amazon, and maybe a little some of the other clients you have and what you guys are doing for them at the moment?
So Amazon as one of our clients is, I would say, the typical type of starting point for sales at SolCold. Meaning either we get approached by a customer, listen, we heard about you, what you do, this is very fascinating, let's talk, let's start to see if we can do something together, or we meet them either in exhibition, or either we approach them directly or through other, but it's the same thing. And then comes the point that after a short conversation, we say, listen, our solution will cool you down without electricity, and it will, of course, save you energy for your efforts to cool down using your chillers or air condition, whatever it is that you're using. It will allow you to manufacture or maintain your 100% efficiency working through heat waves, etc. It will reduce maintenance, and there are other things that we can talk about. Then after this, there was always the state of, okay, we want to try it. But it doesn't really mean that you're going, okay, we believe it. What you're saying is magnificent and we trust you completely. Although you are a startup, and then give you the entire warehouses of Amazon and just deploy. It doesn't work like that. Always there's a phase of test. And this is exactly where we are right now with Amazon. It's a warehouse in Sevilla, in Spain. And specifically in this part, we are competing head to head with another company. So in this domain, I would say of the materials with the goal, outdoor materials with the goal to reach as lower temperature as possible, we're not alone. So there are legacy companies and you have some startups globally with pretty much the same attempt, but slightly different technology to reach the same goal. One of them is an American startup, and we are competing head to head with them in this.
What do you guys do different or similar?
Well, they do it in a form of a liquid form. We do it in a form of a solid form. They're not doing the up conversion nanoparticles at all. They're using higher emissivity molecules and then try to reflect pretty much as much as possible. Pretty similar to quite a lot of product out there, but as a startup, they're promising much better results than the usual suspects like Sherwin-Williams and PPG and Henkel and all of these guys at 3M. So this specific pilot is the rooftop of the warehouse where you have the condenser units. These are the heavy machines that are on the rooftop that are pretty much responsible for then pumping in the cold air towards the building. Okay, it's put in simple way, complex. And then both us and the other startup take a different part of the rooftop with the condensers devices there, measuring temperature before we do anything on the rooftop itself, on the air floating on the rooftop, on the air inlet to these condensers and different places, and then do the work with the coatings. Each one on their own part, and then measuring again, measuring power consumption, measuring temperatures inside, outside, day, night, etc., etc. This will go on for several months until the summer of next year. At the end, the goal is usually the same: save as much money as you can with your solution. And then once you save as much money as you can with different ways, mostly from energy consumption, but also from maintenance and also from allowing productivity or increasing productivity, at the end, you're gathering everything, all this data, comparing that one to the cost per square meter of applying your solution. And with that one, you're getting the return on investment for Amazon. And with that one, they will also get the results, which I'm pretty sure that will be better on our side. It is usually the case on every other pilot that we did worldwide, really every pilot that we did with every competitor. And at the end, it's going to be how much does it cost? How much does it give? Then if that one makes sense, and it should make sense, then okay, let's do the entire warehouse in Sevilla, and then we have another one in southern France. Let's do that one. So that one is with Amazon. Now, Amazon also, as a company, also defined itself, by the way, like many other companies, really what is their sustainability goals. Really, where do they want to reach? Even now, by the way, with Trump in power, still companies have this. So they want to reduce their energy consumption. They want to reduce their footprint. They want to reduce their CO2 emissions. The other part of the plans from previous years, they are slowly neglecting all the quality of races, etc., but they're leaving the part of the energy and the sustainability. And this is where we come in.
And give some additional examples of a typical client you're pursuing.
Another one very important client for us is a company called AB InBev. It's a holding company in the brewery market. I think they own something like 500 brands globally of beer. Meaning pretty much they have production factories of beer in every country in the world, and in most countries much more than one. Now a brewery, industrial brewery, looks usually like these very big metal silos, very high and very wide, and you have several of them, which for the process of making the beer, the fluid goes from one to another, and then stays there for several weeks, and then go to another, etc., until the beer is ready. Not an expert on this one. I just know you have the malt, you have making the sugar, you're making the alcohol, and then barley, something like that. Anyway, the process is a very temperature controlled type of process. So they need to be at this temperature for this long, and then this temperature for this long, and go back to this temperature for etc. It is a very controlled environment. So of course, in every of this huge silo, they have mechanisms to reduce temperature or to increase temperature, like chillers, like it's a liquid type of chillers. Okay, so they pumping liquid inside pipes inside these silos, the envelope, and then these liquids are in certain temperature and then cool down or heat up. With them right now, we are in the third silo that we are doing. Each one of them is something like $100,000 of a sale, and it is the most interesting part of it is
One
that
second. Each silo, it's $100K investment on their part.
$100K US dollar deal for us.
First.
It's a huge thing. That's what I'm saying. So the interesting part here is that on top of reducing their energy consumption for the cooling, which is something that we know is going to happen, since right now in the global warming, or the way that is now being expressed, not global warming, but climate change is more or less more now, you get more frequent heat waves and more longer heat waves. And that is that has a very interesting effect, meaning because these type of silos and these huge machine that they have installed several years ago, now with the increased heat waves, they don't manage to reach the temperature that they need to reach. As a result of that, they are halting their production in these days of the heat waves.
So it's not only an issue of expense, it's an issue of lost revenue and lost production.
Yes, actually increasing their production period, productivity. With them, we increase their production by 0.5% in this silo. Maybe sounds a little, but it's hundreds of thousands of dollars.
Yeah,
0.5%. And this is something that I really, really like, because it's an excellent added value, and it's a no-brainer for them. Okay, let's do another one, and then go spread it to all of their sites globally. Look at the SolCold solution. Look what it did to us.
So another question I want to bring up to you about, so let's say, is there a contradiction between using solar panels on warehouses and roofs and using your solution? Is it an either or?
Not exactly, but it is a competition on real estate, right? Real estate on the rooftop. Solar panels, PV panels is something which is well established. Everybody knows that it is working. There is no really question. There's not really much. The calculation is quite simple. Exactly what is the return on investment that you will get from installing your solar panels on the roof. It works. It works fine. Solar panels can survive something like 20, 25 years even, until you need to replace them. Something like after 8 years, it will return the investment. And then from that point onwards, you're gaining money. The only minus side of solar panels is that solar panels generate electricity is something like 15 to 20% of the solar spectrum. The rest of it, they're absorbing it and heat up. So if you can tolerate the heat coming from your rooftop because of your solar panels, no brainer. The way for us to combine this is, and this is something that we did quite successfully in several projects, is that once you have the rooftop of an office building or of a structure which has several elements on the rooftop, like the condensers, like pipes, and even the solar panels, but the solar panels are elevated, meaning they are not stuck to the floor. They are like that. And especially when they are like that, if they are bifacial meaning they have a solar panel when they're like that here, looking at the sunlight, and also here on the bottom, looking at the ground. And because they are so cheap today, these solar panels, it makes more sense to install these bifacial today, cost almost the same as single one. And whatever will be reflected from the floor, okay, we can generate slightly more electricity. Why not? And this is it's a perfect situation for us. It's a perfect storm for us. because we are, in this type of scenarios, we're coating the entire rooftop of the office building, of the structure. And then we are cooling down everything, all this air that is floating there on top of this structure, all this air that's coming to the condensers, all the air that is around the pipes, all the air that is around the solar panels, and also are reflecting as a byproduct of the cooling. We are reflecting a lot of frequencies, a lot of photons, and all these photons can then be reabsorbed in the backside of the solar panel to generate much more electricity on that one. So it's one system to bring them all into higher efficiency, lowering the energy consumption for it all, and then to generate, again, that on that examples we were reaching like 1.2 years of payback time.
So again, so it will cut down the payback by 2 years. That's your estimates. Is that what you're saying?
It will pay itself in 1.2 years, the entire material and installation.
The panels, including the panels?
Including the panels, including the reduction of energy consumption from the condensers.
So instead of 8 years, 2 years.
The solar, the PV panels,
it's a different.
their
Okay,
average is 8 to 10 years. I'm not talking
Okay.
about that. I'm talking
Got
about the investment to put SolCold on the rooftop.
SolCold, okay. SolCold what I'm trying to understand, when you say 2-year payback is for the SolCold installation or for the SolCold and the panels installation?
The SolCold installation.
SolCold.
It's
Got it.
1.2 years, not 2.
1.2. Got it. 1.2 years.
You
So
want
when
more
you,
examples?
excuse me?
You want more examples? We're not
Give it
doing
one more. Like, give it one that you're really excited about.
I'm excited about many of them. We're doing one which is very exciting, that we are cooling down batteries for the entire solar panel fields. It's a huge field. Right now, there's storage thing not directly connected to the grid, but storing it on
Yeah.
batteries and then connecting it when it's needed. Batteries is an excellent use case for a type of coating, again, with all the heat waves and all the energy consumption reduction. I really, really love it, especially in hot areas of the world. Data centers, also something that I really like, and we are also doing mainly in containers. Containers on general, it's just something that it's like the very simple, non-exciting thing, but containers themselves, I mean, we are talking with a shipment not companies, actually, to make a new type of container. I mean, you have until today the regular type of container, which will heat up drastically under sunlight, getting to 50, 60 degrees inside, and you have the chilled or the cooled container that will maintain, it has a chiller, and it will maintain the temperature that you will desire. Let's say 4 degrees if you're exporting or the shipping of meat, dairy. And you have nothing in between, from the 50 to 60 degrees to the 4 degrees. This is where we come in. So to make the container which will now be shipping electronics or shipping batteries or shipping everything that has sensitivity to temperature, but this doesn't really need to go to the 4 degrees. Then we can maintain them at sub-ambient temperature, whatever the ambient temperature. Go from, in Dubai, it will go to like maximum 35 more or less, and then here to something like 25, all the range from that one to that one. Anyways, also an interesting one. We are also going into fabrics right now, which is also a very interesting, but I will stop now.
So maybe let me ask you a different question. But if you look back at this all, since this initial idea you had when you were with your girlfriend to today, when you're looking at fabrics, containers, like solar battery coolings and so on, what do you say surprised you the most about the journey?
I don't know. What surprised me the most that I got here. I mean, at that point in time, as I told you, I just neglected the idea for something like 7 years. I didn't know what to do. I didn't know how you take a theoretical idea and make the 0 step. I don't think I even imagined at that point that I will speak about containers and batteries and going into textile and even semi-transparent and working with Volkswagen and selling to the IDF. Not at all. I mean, I'm a dreamer, but I'm a realistic guy.
Yeah.
So I'm pretty much always looking at what's next for me. What's really, I'm almost seeing it. How can I get to that one? And once I get to that one, starting to see the next blurry thing.
So what is the next blurry thing?
Next blurry thing is something boring, really. We're working very, very hard to lower the cost of a square meter of our product. How boring that sounds.
It doesn't sound that boring. It sounds very important.
It sounds so boring. And the interesting part of it is that we don't do that in a business type of way, meaning moving the production to Bangladesh and then make a sweatshop for 12-year-olds. We're doing this as an R&D project. We're doing that the startup type of way. So we're thinking of how to get the three physics phenomena that allow us to get to the subambient temperatures, the reflectivity, up conversion, and the emissivity, and to get each one of them in a different way, which will use less expensive material, but to get to the same result in a new technique that will allow us to use this much lower type of material. I don't know if that one makes sense too much.
So explain.
So what we're doing in that project is taking the way for us to filter the solar spectrum, so to get a reflectance of some of it and then to allow the penetration of some of it. And we did a research, theoretical research first on what is the best type of levels of materials and holes and the diameters of the holes to get the same frequencies that we are now allowing to penetrate and allowing to reflect back. Right now we are doing that with a 10 layers one on top of the other, which are in the same range of inside of it. Then you get the theoretical journey of the photon penetrate to a certain point as a certain frequency, right? And we tried to spend something like 1.5 years just to analyze the best efficient way to make this journey for the photons, but when the holes are in different shapes, depending on the different depth that it has. So the amount of refraction that it will get will be much more than that at a lower depth than it has right now. Hope it makes sense more up until now. And we come up with after the theory study of really the amount of holes, diameters of the holes in every 14 nanometers of what should be done. And to get that one, because you cannot really manufacture, or you can, I suppose you can manufacture this amount of holes in every single 40 nanometer, but it will take a lot of money to do that. So instead of it, we're using the same material with the same amount of holes, but penetrating to these holes certain nanoparticles that in every part it will make the different diameters of the shape. And in that way we can use more or less half the amount of this material with the holes to get the same result. That one was boring or not?
I think it's basically a lot of like making theory into reality. That's if I understand correctly.
You know something cool?
Yes.
We did a project with Volkswagen. I mean, we were working with them for something like 2.5 years now. And this August, that was 2 months ago, the first demo car with a sunroof embedded SolCold material inside was demonstrated in their biggest event of Volkswagen to their entire group. People were entering my car. People were entering a SolCold coated inside the glass of the sunroof and going to the next car without, and said to everybody, that is actually colder.
So it is cool, pun intended. It is cool, twice the cool.
Yeah.
What's the future? What do you see? When you look, so we said about the near blurry, but if we go back to the dream, like what was the dream?
The near blurry is to complete the project of the reduced cost. This is the near blurry. And then this is the marking point, I would say. As you know, as a material type of startup, you have significant cost of production, of delivery, of logistics, which doesn't happen in software. So way to scale up. It's not like that really. Like the software it's a jumbo jet taking off. Okay, it's not a F-16.
It's not zeros and ones. It's not zeros and ones moving in. It's not zeros and ones moving through the internet. You have to move physical things in real world.
Yeah, that point of able to produce at something like 50% of the cost that we are producing right now is the most important part of this graph of going here. This is the exact point over here. Lifting, and then lifting, exponentially lifting. That is the triggers. So where will we be in few years from now? A material company with a portfolio of products that we have developed from our core technology, taking this to different domains. I mentioned the textile, I mentioned the transparent or semi-transparent that we're doing with Volkswagen, but we can go pretty much on anything. You can match it to different climates. You can make it not cool at winter time and then match it also for the cold countries. We can go really in any direction that we want. At the end, an established material company, a 3M of developed from the Israeli startup.
Amazing, exciting.
It is. We just need to get there, and this is what we are all working on.
So if somebody hears it and wants to find you, where should they look? How can they contact you?
Well, we have our website, of course, so we can look at other data and then pretty much see what we do. www.solcold.co, only co, not com. Can contact me with my email, which is Yaron, Yaron @solcold.co, or maybe through this platform. I suppose if anybody, is there a chance to leave messages here on this platform?
Not here, but we can. In the show notes, I will put your LinkedIn in the. I will put you right well.
And for, of course, any investors that wants to join our journey, this is something that I'm most welcome, of course. I mean, in the beginning of my job was R&D and then sales and then everything. I think it goes narrower slightly over time, and my job is mainly right now to bring money to the company. So
amazing, Yaron. Thank you very much.
Okay, thank you very much. It was a pleasure.
Pleasure.
It was actually, as you said, something like 1 hour plus, and I didn't really notice it.
What? Time flies when you're having fun.
Okay, thank you very much. Looking great as usual.
It's a wrap. This Ageas podcast episode ends here, but you don't. Now, is it crazy to think that you know somebody who'd love this episode? Share it with them, and they'll love you for it.